The foil that we thought was solid does not seem so solid after all. What analogy could we think of to explain the results of Rutherford's experiment? Shooting the alpha particles at gold foil might be likened to firing bullets at an iron grill fence. Usually, the bullets pass through the fence undeflected. Occasionally, one hits an iron bar and ricochets. It might have been this kind of reasoning that led Rutherford to the conclusions of his experiment. He concluded that the atom is mostly empty space, composed of a small, heavy, positively charged nucleus, surrounded by tiny negatively charged masses, the electrons. Rutherford's model, also called the nuclear model of the atom, looks like this. If the nucleus were the size of a ping-pong ball, the radius of the atom would be about 2 kilometers. This would explain why alpha particles go through 99.9% of the time. The positively charged alpha particles have a mass 4 times that of the hydrogen atom. On the other hand, electrons are relatively small and light and do not deflect the heavy, fast-moving alpha particles. When an alpha particle comes close to the nucleus, it is deflected from its straight-line path because of the mutual repulsion of 2 positive charges. A direct hit on the nucleus would send the alpha particles back to its source. Rutherford's model raised many new questions. How are the electrons arranged around the nucleus? What is the nucleus made of? A number of years later, some of these questions began to be answered. Changes in the Rutherford model were made.